Hi, I'm Matt Hall, and I'm here to present to you work that was done in collaboration with Sathiya, Durairajan, and Paul Barford on characteristics of metro fiber deployments in the US. The motivation of this work is to study fiber deployments in the United States because these are critical for information to businesses and to large segments of the population. Metro fiber sits between long haul and last mile broadband connections. The focus of this work is on presenting the characteristics of metro fiber in terms of service options, the robustness of deployments, the density related to populations, and the proximity of this infrastructure to data centers. To do this study, we look at 204 distinct metro fiber maps from the Internet Atlas. And a subset of these maps are now available on Impact, and at the end of this talk, there is a link to those data sets. So this map shows metropolitan area fiber in the US. These areas are divided into metropolitan statistical areas, or MSAs, and so that is why it seems like there's sort of little scatters of these about. These maps are shown to be representative of where there are population centers in the US. And as you can see, zooming in on these shows us more and more detail down to the street level as we zoom in. So the maps that are zoomed in on here include Portland, Oregon in the top left, Chicago, Illinois in the center top, Phoenix, Arizona in the bottom left, and Miami, Florida in the bottom right. In all of these metro areas, we also study or try to find out how many different providers there are in each of these areas. And so this graph shows the cumulative distribution of the number of providers in each MSA. So most MSAs have 5 or fewer different providers represented in these maps, and a very small number of them have 10 or more. This plot shows the fiber density versus population density in the United States. So on the y-axis, we have the number of raw fiber miles present in the metro area, and in the x-axis, we have the 1,000 people per square miles. So in this, we see some interesting outliers, such as New York, Los Angeles, Chicago, all of the large city centers that we see are represented here. And it seems like Los Angeles has the highest population density, or 1,000 people per square mile, while Philadelphia has the highest fiber miles, or the largest number of fiber miles. And New York is sitting between those two with quite high numbers for the total fiber and also for population density. So how do we compare deployments of fiber in different MSAs? What we wanted to do is come up with a ranking measure to stack these together. And it's not sufficient to just look at the total number of fiber miles that are present in an MSA, because MSAs are also different sizes and they serve different kinds of populations as well. So a smaller MSA might not have as much fiber in it just because it's a smaller area. Also, a large MSA might have a small population density, and it might just not need as much fiber. So we wanted to come up with a ranking measure that could capture both of these things. That would increase with the total fiber distance, and a rank that would decrease with population and with land area. So we looked at 2 key statistics, particularly availability and density, where availability measures the number of fiber miles per person, and the density represents the number of fiber miles per unit area. And so this graph shows both of those measures plotted together. And here we also see some interesting takeaways now too. The largest MSAs that were present in the last graph, that we don't see too much on the outliers here, particularly that Los Angeles area and New York have gone closer down into the center or the bottom left of the graph where the clustering is. And on these outliers, we're still seeing Philadelphia, but we're also seeing new ones, including San Jose, St. Louis, and Cleveland. Another way to look at metro fiber is in terms of clustering. So Moran's I is a spatial autocorrelation index that tells you how similar a geographic feature is to other features of its type and its area. So we ran this clustering analysis on several MSAs, and below we see those for Miami and Portland. And the intuition behind this kind of a view is that areas with high clustering, such as these red lines, the intuition is that these are well planned out and thought to have been placed in order to service the large population in that area. Whereas the blue or lower autocorrelation indexes correspond to areas that might have been provided or provisioned more opportunistically or sporadically as the needs of that area increased. This view also gives us a way to see areas of shared risk in the network where high autocorrelation also could imply more risk, or areas where there should be more redundancies built into the network. This graph shows the New York metropolitan area outlined in black and the fiber within it in blue. And so visualizing it at this level, it's a little bit difficult to take away some key insights or to learn anything from the map at this point. So we needed to come up with a way that we could get insights about the map from a glimpse at it. And so to do that, we ended up coming up with this map shown here. So this is 11 square mile hexagonal grid placed over the border of the boundary of the metropolitan area. And within each of these hexagons, we came up with the sum of the fiber distance within each hexagon. So hexagons that are red or orange or yellow have a higher total number of fiber distance within them. And green hexagons have lower fiber within them, and then areas without a hexagon just don't have any fiber. So what's interesting to take away from here is that we see not just areas with high fiber, but we also can see the paths on the map where the most fiber is also traveling, such as the yellow area coming down from New York City Center. So that shows us that there's a high amount of fiber in that area, and that could be potentially, some place that we would want to add new alternative paths around to sort of reduce risk in the network, things like that. Finally, we also conducted this data center study to see how many or how close the data centers are to the fiber infrastructure, or how close any given area in a metropolitan statistical area is to a data center. So to do this, we utilized that hexagonal grid from the previous slide. And what we did was we calculated the distance from the center of each one of those hexagons to its closest data center on the map. And from there, we looked at the total distance within every metropolitan area to its, from each hexagon to its nearest data center, and we came up with these measures. And so what we take away from here is that Los Angeles, New York, Boston, and Washington, D.C., these four metro areas all seem to have the best or the most proximity to data centers within them. whereas the other population centers like Miami, Chicago, and Dallas and Houston, they don't have as many data centers in them, and these show in areas where the infrastructure could be improved by putting more data centers there to increase the proximity to users. So as a case study, a little exercise in here, we looked at improving data center connectivity in the New York metropolitan area, kind of hyper zoomed in on the Manhattan island. So on the left, we see line of sight distance from hexagonal or from centers within the New York MSA. And on the right, we show prospectively where new data centers could be added to reduce the distance for the most amount of people. And so we did this for varying numbers of new data centers that could be added. And we found that for the New York MSA, we kind of hit a point of diminishing returns, or around 5 to 10 new data centers that are added. So that shows us that the New York area doesn't need that many new data centers, but just a few well-placed ones can increase the proximity for a lot of different users. So those are just some of the things that we were able to do with Metro Fiber maps. It's still part of our ongoing study to look at new applications about how these maps could inform future deployments and what other things that we can learn about internet infrastructure with them. So if you want to look at the data, you can go visit this website at the impactcybertrust.org and request the data there. And then I'll be here after the talk to answer questions. Or of course, if you're watching this in the future, then you can email us too. Thank you.